Hey everyone, and welcome. Today we're diving into a really cool story about how one simple but totally brilliant idea managed to fix a massive flaw in a revolutionary AI vision model. It's called Deformable DETR, and it's all about how teaching an AI to focus made it way faster and a whole lot smarter. Let's get right into it.
But first, I want to kick things off with a question for you. Have you ever wondered why some of our most advanced AIs, the ones that are supposed to be amazing at seeing and identifying things in pictures, are just incredibly slow to learn? Why does it seem like they're seeing the world in slow motion when they're training? Well, the answer to that question is really the whole reason we're here today. So to understand the fix, we first need to talk about the original model, which is called DETR. Now, DETR was a huge deal when it came out. It was the first fully end-to-end object detector. What that means is it threw out all the clunky, hand-designed parts that older models needed. Things like manually defining box sizes or writing complex code to filter out duplicate detections. It was just a much cleaner, more elegant way of doing things.
And the promise of DETR was massive. A simple system that could find objects without all those messy, handcrafted rules. It was a game changer, and it actually worked. But there was a huge catch. It had some really serious problems. For one, it needed a staggering 500 training epochs. That means 500 full passes over the entire dataset, making it 10 to 20 times slower than other models. And on top of all that, it was just terrible at spotting small objects. So what on earth was going on here?
Well, the problem wasn't the big idea itself, but the engine it was running on. The issue was buried deep inside the core of the model, in something called the attention mechanism. The researchers who created it actually said it best themselves in this quote. Basically, at the beginning of its training, DETR's attention modules were giving pretty much equal importance to every single pixel in an image. It was just looking everywhere all at once, with absolutely no focus. Let me give you an analogy. Imagine trying to read a book by staring at every single letter on every single page, all at the same time. It'd be impossible, right? You wouldn't make sense of anything, and it would take forever to find the words that actually matter. Well, that's pretty much exactly what DETR was trying to do. This kind of brute force approach is at the heart of standard transformer attention. The model has to calculate the relationship between every pixel and every other pixel in the image. This creates a massive computational bottleneck that just grows exponentially. To put it simply, if you double the image resolution, the amount of work the computer has to do literally quadruples. This is why the model was so slow and why it completely fell apart on high-resolution images, which you absolutely need to find small objects.
Okay, so the researchers behind Deformable DETR saw this problem and came up with the much smarter way to look. Instead of looking at everything, what if they could teach the AI to focus on just a few key points? This is the central idea that changes everything.
So, they created what they call the Deformable Attention Module. It's this super efficient mechanism that, instead of looking at every single pixel, only pays attention to a small fixed number of key sampling points. It basically learns to just check a few crucial spots to get all the information it needs, no matter how big the image is.
So if we go back to our book analogy, this new approach is like having a magical guide. Instead of letting you scan every letter, the guide just points you directly to the handful of most important words on the page. You'd understand the story so much faster.
And what's so cool is that we can actually see this in action. This image shows the attention points the model uses to spot a zebra. Those little red and blue dots are the key points the model chose to sample. And just look at that. It completely ignores the background, it ignores huge parts of the zebra itself, and it focuses only on the specific features it needs to make a decision. So clever!
Okay, so that's the big idea. But how did they actually implement this? Let's take a look at the architecture to see how this new module fits into the model. The change is actually surprisingly simple and elegant. What you're seeing here is the Deformable DETR architecture. The researchers basically just took the original inefficient attention modules inside the transformer and swapped them out for their new efficient ones. And as a bonus, this new module can naturally look at features at different scales, which is absolutely critical for seeing both big and small objects in the same image. So we've got this clever new design. The big question is, what does it actually achieve? Well, the results are, to put it lightly, pretty spectacular. This wasn't just a small tweak, it was a massive leap forward. The biggest headline number is right here, 10 times. Deformable DETR gets the job done and gets it done better in just 50 training epochs compared to the 500 that the original model needed. That's a tenth of the time. Just incredible. And this table here really spells it out. It compares the models after just 50 epochs of training. Look at the overall accuracy, or AP. Deformable DETR hits 43.8, which is a huge jump over the original's 36.2. But the real kicker is the score for small objects, APS. It goes from a pretty weak 16.3 all the way up to a really strong 26.4. So it's not just faster, it's way more accurate, especially in the exact area where the original model was weakest.
So let's just recap why this is such a big deal. First, training is just dramatically faster, which saves a ton of time and computational resources. Second, the accuracy is much higher, and it fixes that critical weakness with small objects. It also handles features at different resolutions without any extra hassle. But really, the most important thing is that this efficiency opens the door to building even more powerful and advanced vision systems in the future.
And again, this isn't just about numbers on a chart. We can literally see how the model learns to focus. When it looks at the zebra, it zooms in on the unique patterns of its stripes. For the car in the rain, it zeroes in on key features like the headlights and the windshield. In every case, it has learned to find the important signal and ignore all the noise.
So, this incredible work solved a huge problem just by teaching an AI how to focus. And that really leads to one last big question. By making our AI systems more targeted, we're not just teaching them what to look at, we're also teaching them what to ignore. So, if an AI can learn to focus its vision, what other distractions, biases, or irrelevant junk can it learn to ignore in the future? That's definitely something to think about. Thanks for watching.